Or in a situation like lim, yeah, when you're stretching your lim graph, for like y equals to 3x, so x equals 1 over 3, and for the
You just mark off 1 over 3 on the x-axis as the root, that's fine.
y.
X is 1 over 3, y will be 0.
Why? 1 over 3. Why is this 1 over 3?
If x is 1 over 3, then you have log of 3 times 1 over 3. You said log 3x, didn't you?
Link 3x.
Yeah. So log 3x. So that's log 3 times a third. What's 3 times a third? 1. What's log 1? 0.
So, can you say what you said, why it's constant 1 by 3?
What I'm saying?
No, why does the question is
That's what I'm asking.
What's the question? Y equals
natural log
3x. Okay, so we know, because it's positive, that the graph will look like this. Okay, so you're happy with that, yeah? So the real question is, where is this? Okay, well, we know that log of 1 is 0. So this point here must be where this guy is 1. So when is 3x equal to 1? When x is a third. You see, you're disappointed now, right?
Yes. So that point will be 1 by 3.
That point there is a third, yeah.
What if it has a coefficient?
If it had a like here,
You just multiply.
that is still the same.
So what is the impact on the 4 then?
It doesn't impact on the root.
Okay, so it's still 1 over 3?
Yeah.
What is the impact? What is
It wouldn't.
the graph? What is the impact?
It will flatten the graph a bit.
Yeah, it will impact the slope.
But I mean, because you're not marking off values on the y, you can't really tell. Okay.
But then if you were dividing by something, that would change the graph.
Yeah. Continue now. Oh, quickly.
Is it right?
Which one am I looking at? Log A B B C equals log AC. Let me think. Wait, where did A come from? Did you mean? Oh, that A. Give me that. Let me think. What base is this? Base A. Wait.
No, it's just look on this.
Yeah, but this needs to have a base.
Yeah, 10.
Oh, right, 10. Oh, I see. This is base 10, huh?
Yeah.
See.
And over log 10.
Why are you doing this to me? But they cancel.
And then let's see.
Yeah, okay, that's log 10c over log 10a, which is the same thing as log AC. That's log 10c over log 10a. So that would be log 10c over log 10a. I don't know if I can get it back to this. I think you maybe meant to say log base A of C. That's what I think you meant.
I think I just remember. we just
Maybe you misremembered.
I'm getting the shift.
I'm not sure about this. Do you know how you could check it? Put in some numbers for ABC and see what happens. Yeah. Oh, quickly, yeah. Yeah, same idea. Yeah.
So this one's 1.
So this one, the X is a quarter, yeah.
So
Yeah, that's
one,
right. Yeah, so it becomes 1, yeah.
If we get to this step in the present and like.
Oh yeah, you choose your calculator. Yeah. Okay, let's continue. Guys, we're continuing now. We are continuing now. Amjad, could you take his headphones off, please? Thank you. We're continuing now. Right. So, exponential equations. So, in this lesson, what we're going to do is look at using our rules of indices to solve some exponential problems. So, let's have a look at some examples here. So, we'll say we have something like 2 power x minus 1 equals 8 power minus x minus 3, and we want to solve this. Right, so we should be able to solve this by only using our rules of indices. The first thing I want to do is just change this into 2 power x minus 1. And this one here, I'm going to change the 2 cubed, 2 cubed. And its power is still minus x minus 3. Now, which rule of logs should I use to simplify this next? I think it's the third rule. No, not that, quite that one.
Move the x minus 1 is equal.
Is that rule 3? So what I can do is I can multiply in the powers. So this would be 2 power what? Minus 3x minus 9.
Now, you compare.
Compare the powers. Take out the 2.
Yeah.
Because if you have 2 power A equals 2 power B, the only way that is possible is if the A and the B are the same. There's no other way it could be possibly true. So here, it has to be the case. It has to be the case that x minus 1 equals minus 3x minus 9. No other possibility is allowed.
4x.
So, 4x is equal to minus 8.
Oh, no.
So then x is equal to minus 2. Make the base the same. So here we managed to get both of them as 2's. Now that's not always possible, but in today's lesson it's always possible. But in a later one it won't be. So if you can write this one down, we'll do another example. Got this? Not yet. Which is what I said. Yes. I thought so. But this is my point. When you have too many rules, you can't remember them accurately. So this is why I tried to stick a 5. Yeah. Okay. Do you have this? Yeah. Moza? You have it? Nearly? Yeah. Did you eat a packet of shortbread, M&Ms and crisps for breakfast? And I'm sure there's something in the crisps. What's in the crisp package? More what? Okay. Yes. All right. Next one now. Can I scroll down? Yep. Okay. So now, a little bit harder now. No, 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 not necessary. Yeah, yeah, that's asking too much. Right. 3 power 5x minus 6 equals root 81 power 2x plus 6. Now, it looks a bit harder, but it's the same ideas as the last one. So the first thing I'll do is I'll change that 81. Well, the 1 over 2 I'll get to in a moment. But what should I change the 81 into? Yeah, 9 squared or 3, 4. 3, 4. 2x plus 6. So this is 3 power 5x minus 6 equals root, and again by using the third rule, that would be 8x plus 24. Yeah? Now we have to take care of the square root, which Mo, you said what to do here. Yeah, yeah. This is 3 power 8x plus 24 a half. And once again, we use the third rule. So this is 3 power 5x minus 6 equals 3 power 4x plus 12. When you multiply in. Yeah, yeah. 5x minus 6 must equal 4x plus 12. So that means x must equal 18. Okay, did we write this down? Now the next one, who was asking me about this one in the tutorial? You were asking, weren't you? Yeah. So the next one is very similar to what you were asking me. So I think you'll be able to do it after you see this example. So, can I scroll down? Okay, so the next one now. So we have 9 power x minus 82 times 3 power x plus 81 equals 0. What should I do first here? Any ideas? Yeah, I should change the 9 to 3 squared.
And the 81 as well.
Perhaps, let's see. This is 3 squared. 3 squared to the power of x is 3 power 2x. Right, what should I do next now? Yeah. Or what I'll do is I'll just rewrite this as 3 power x. Sorry, I mean to say... No, sorry, I was right the first time. 3 power x squared. So obviously that's the same, yeah? Minus 82 times 3 power x. Yeah. It's a quadratic. Yeah, it's a quadratic in which the variable is 3x. Yeah. I know everybody wants to substitute, but I mean it's so obviously a quadratic, I'm going to skip the substitution. I mean it's obviously a quadratic because it's like, this is like something squared minus a number times something without the square plus another number. You know.
Minus 1 times x.
Yes, we should be able to factorize it, yeah. We can factorize this, but you can use the quadratic formula. But anyways, let's see if we can factorize it. So we need two numbers which multiply to make 81 and add to make minus 82. Minus 81 and minus 1. They multiply to make 81 and they add to make minus 82. So we get 3x should equal 81, or 3x should equal 1.
Now you just have 81 as a power of 3.
Yeah. So 3x equals 3, 4, or...
X is 0.
Yeah, what's 1 as a power? 3 power 0. So we get x has to equal 4 or 0. Yeah.
Flexible which I think easier by turning 3x to x.
Yeah, that's fine. Just don't call it X, give it a different letter like Y or U or something, yeah. They don't actually, you can do that, that's totally fine. They don't actually expect you to do that in the exam. Yeah?
With powers, like, with 0 work?
Yeah. 9 power 0 is 1. 3 power 0 is 1. Okay. 1 minus 82 is minus 81 plus 81 is 0.
Yeah. You're right, yeah. I forgot to take into consideration
Yeah.
they were not given.
Is that okay now for you? Do you think you could try your example? Like, do you think it's possible for you to do it now? Or, it's similar, isn't it? Yeah. Yeah.
This 3x equals 81. Is it okay if we say log 381?
Yeah, you can. I didn't because it's not necessary, because 81 is a nice 3 power.
Yeah.
In some questions though, this is not possible and you will have to use logs, but not in today's lesson. Yeah. In the exam it can go either way. Sometimes it finishes up nicely like 3x equals 81, but sometimes it might be like 3x equals 4. And then you're right, you'll have to use logs. Okay, next example now. This one is like a section A question. 2x power minus 3/4 equals 10x power 9/4. Yeah, what should I do first here? There's two things I could actually do. Yeah. Yes, go on. What could I do?
You can make that 9 now.
Nothing with the 9.
You can make the 10 2 powers.
Let's not.
Minus 3 plus 3 over 4.
Nearly.
9 over 4 is minus.
Divide by 2 on both sides.
Okay, there's two things you can do here first, okay? You have two approaches you can take. I'm going to show you both. So the first thing I could have done is I could have done a little bit of cross multiplying. So I could have put the x minus 3/4 and the x 9/4 on the left and the 10 over 2 on the right. Just cross multiplying. Bring the 2 down and bring the x down. Now why bother? Well, 10 over 2 is easy. And here I subtract the powers. So minus 3/4 minus 9/4 is minus 12/4, which is x to the power of minus 3, which is 1 over x cubed equals 5.
Which means 5x cubed is equal to 1.
Yeah, swap it around again. 1 over 5 equals x cubed. So then x is what?
No, or you could have just kept the 5 there and you could have gotten that.
What's x here at the end?
Let's use log now.
No, logs. What's the x here?
1 over 5 times 1 over 2.
No.
Log.
Cube root a fifth. Okay, if you say so. Right. But I said there's another way to do it, which it's nearly the same, but it's a little bit different. So you have 2x to the minus 3/4 equals 10 power x, 10x 9/4. Okay, the first thing I'll do is I'll just divide by 2. So at least that guy now is 5. So I have x minus 3/4 equals 5x power 9/4. Okay? Now what I'll do is, next I'll put both to the power of 4/9. I'll put everything to the 4/9. Now why bother doing that? Well, what's x 9/4 and 4/9? What happens here?
1.
1. Yeah? It's still actually a little bit messy, isn't it? Maybe not 4/9. it amounts to doing the same thing actually, I think about it. I'll bring this underneath and that's 9/4. So actually, I'm sorry, the only difference really is, the only difference actually is at this step. So, does anyone have any other ideas on how I could continue? That's the only difference. Yeah, yeah. That's what you were telling me. Yes, yes. It is the same thing. If I wanted to, I can put both sides here to the power of a third. Because what happens here? They cancel, yeah. But, in fact, if you're really thinking about it, this other method, what you could have done, you could have actually done that earlier. You could have done that as far as early as here. Because if you have x to the minus 12 over 4, now 12 over 4 is actually an easy number here. It's simplified. In some questions it doesn't. You know, you might have minus 12 over 5. Okay? Let's just pretend it doesn't simplify. You can actually skip all of these steps. How could I skip all of these steps? What power would I need here? It would be negative 4 over 12. Because they cancel down to leave me with x power 1. And this is 5 power minus 4/12. Which actually you realise is the same thing. This is 5 minus 1 over minus 1/3. Anyways, I don't particularly mind which way.
Just leave it as minus 4 over 12.
In this case, you can simplify the 4 over 12. What I'm saying is, in a lot of questions, you can't actually. It'll be something like minus 4 over 13 or something. Yeah. It doesn't really matter which one here. I kind of feel like most students prefer just to do it this way and not think about what number you can use to cancel that. Yeah. That one there, 22. Okay, got that? Now, just before I continue, I don't want to forget to tell you, I had HS2 first, didn't I? Yeah. HS2, it would be useful for you to watch the tutorial from HS1 because I did stuff in that you didn't do, and vice versa. So HS2, if you watch HS1's tutorial, I'm actually doing a couple of exam questions in it. And likewise though, HS1, you should watch HS2's tutorial, because in their tutorial, we had an interesting example at the start with the graph, with, what lesson was that from? The discriminant lesson, wasn't it? Yeah. You know, and that was quite interesting to see the graph change there for the different values of k. Alright? So, you know, there is some benefit in watching the other group's tutorial, because we're not doing exactly the same thing. You don't have to take any notes, even just, put in your headphones and watch it on the bus, just so you can see a couple of things that you didn't see in your tutorial. Okay. Right, next example now. Can I scroll down? Yeah. Right. I want to know, where does this graph meet this graph? Now, we can actually, we can picture this. The first graph looks like this, and the second graph looks like this. So they must meet somewhere on this axis. Let's figure out, what would be the best method to use to figure out where these meet? Equate them, yeah. So I get this. No, actually. What should I do next?
Compare.
X equals minus x. What do I do next?
Simplify x.
Yeah, how? Divide by x? I mean, what should I do? What action should I take next? Should I divide by x?
Yeah, why not?
Why not? Why not divide by x? What happens if I divide by x?
1 is
Yeah?
equal to minus 1, which is 0.
Take out the minus. Yeah, by doing what?
How much slide am I?
divide by minus 1 will give me this.
You do the same thing. Introduce something.
Now look, just so you know, you can't divide by x. Because if you divide by x, what do you get? X divided by x?
Which is wrong.
Yeah. But why can't I divide by x? What was the mistake in thinking I could divide by x?
You lose the variable?
No? Well, yeah, but why can't I divide by x? Like, there's nothing wrong with that operation.
Why don't you
it seems.
think to the other side?
No. Answer my question. Why can't I divide by x?
Because you wouldn't have a variable.
No, I don't. No, listen. I want to know why can't I divide by x? And I don't want you to tell me the consequence. I know what the consequence is. If I divide by x, I get 1 equals minus 1, which is obviously wrong. But it's wrong because I divided by x, not because of what I got. Why is dividing by x wrong? No, you're looking ahead. I need to know, without knowing the consequence, at this step, why is dividing x wrong? And don't tell me because of what happens next.
Because x and minus x x doesn't equal negative x.
No. Oh, you're saying the actual equation is wrong. Good. Good answer. It's not this, but that is something to consider, yeah. But the equation is correct, though. No, but that's a good answer, though. Like, maybe there's something wrong with the equation. It could have been that. It's not that here, though.
Is it because x and minus x are two different?
No.
Is it
On
because
the graph, you can have
the e values of when you raise it to x and minus x? I don't know what
No.
I'm talking about.
Good. Why can't I divide by x? Now, this is
everything to do with the graph.
No. Okay, you're not getting this, and this is important. This is very, very important. I can only divide by x if I know x can't be 0. Now, I don't know that, because here, conceivably, x could be any value. And here, conceivably, x could be any value. Do I know for certain that x is not 0?
No.
Certainly not. X could be 0. So, I shouldn't divide by x. I should bring that over to the left. Now, I know some of you knew that, but I really want you to know why you can't divide by x. It's because you don't know for a fact that x can't be 0. I mean, it could be 0. Now, if I bring that over, x plus x, 2x equals 0. So what must x be?
0.
And this is why dividing by x is wrong, because not only could x be 0, it actually was 0. And this is why it was wrong too. So, this is not perhaps surprising, because when you think about the graph, they'll both cross here at 1. Yeah, no, I was looking for x, not y.
In the question,
One sec.
if it says where x is equal to 0, you can divide by x.
If it said x is not equal to 0, you could divide by x.
Even though it's crazy like this, like even if it looks like when you divide by x, then there's no.
Second? Okay.
Sorry, you got input the e power minus x in fraction format.
Yeah.
It looks less messy, does it? Well, I wouldn't say if it's easier, but no, you're right. So, Young Peng suggested we put in fraction form. So you have ex equals 1 over ex. And this is using, what is it, like the fourth rule or something like this. And then you can cross multiply. So you get ex equals 1. So that's e power 2x equal 1. And you realize, the only power here that could make 1 is 0. So then 2x must equal 0.
Don't use consider 0 as a private point.
I'm just
But
stretching it out. Yeah.
When I graphed it, it said that the x is minus 3.84 times 10 to the power of minus 15.
Yeah, it's rounding it off.
You know.
Yeah, because that number is essentially 0. Because you have 15 zeros in your number. Okay.
now,
Yeah.
this would only work if the answer was 1, you know? Like,
Yeah.
if
So
you-
what would you do if it wasn't like that?
Yeah,
Okay. So
exactly.
we'll have a look at another example like this then. Yeah. Here.
No, the e is the x
Am I looking at left or right?
Right.
Yeah. Here?
No.
Next? Previous?
Yeah.
Yeah.
This is supposed to be e raised to power minus x.
Oh yeah, which I changed to 1 over ex.
So if it was y equals e, 3ex.
Yeah, it's a little bit different. So we're going to do a different example now that's a little bit harder. Because that's what someone else was asking. So obviously this one here, it's nice that there was a bit of cancelling, but if it's not quite that, let's see. Can I scroll down? Yeah. Okay, so suppose you had something like this graph, y equals 1 plus 2ex, and the other one y equals 6 minus 2 over ex. And we want to know where do these graphs meet. So the first graph, I don't know, whatever it is, it's something like this. And the second one, it's whatever. They meet somewhere, obviously. So I want to know where do they meet. Okay, so I have 1 plus 2ex equals 6 minus 2 over ex. What should I do first here, do you think, to solve this? What's first? It's kind of a bit of a pain that this is in the denominator.
Take 2 GCF. 2 GCF.
No.
2 GCF.
No, I think I multiply by ex. Because that way I can get rid of the fraction. So here I have ex plus 2e,
X squared.
yeah, 2x, because there's an ex and an ex. And this one will be 6 ex.
Minus.
And lastly, minus 2.
Now take 2 GCF and simplify.
Yeah, well...
Or take it to the other side.
Oh, dude, tone it back. Right, 2e, 2x, and then ex minus 6ex, minus 5ex, and then plus 2 equals 0. And now, what am I getting at here? Quadratic. I'm getting at quadratic, because this is like 2ex squared minus 5 ex plus 2. Now I don't need, does this have factors? I think it does it have factors? Could be, perhaps. Let's see. Ex 2 1 minus.
It has 2 and half.
Yeah. These are the factors.
So it has 2 roots.
So yeah, well, in this case it does, but not always. Ex equals a half, and here ex equals 2. No, yeah.
I thought it was supposed to be minus 1 minus 4.
No, because I need to have a 2 in the front here. You can use the quadratic formula if you like. Okay, continue. So look, this problem here should remind you of the log lesson, because look what you're saying here. E to what power gives me a half? And here you're saying, I need to figure out the x. E to what power gives me 2. We have something in mathematics to answer this question already.
No.
It's log base e a half. That will tell me e to what power makes a half. And here this is log base e of 2. And this will tell me e to what power will make 2. So by taking out the calculator and typing in ln 0.5 and ln 2, we have our answers.
0.5 is minus 0.5.
0. What's the first one here?
Minus.
Minus 693.
And the other one is
Minus 0.693.
Yeah.
No.
The opposite.
The other way around.
Okay, just tell me what the first one is.
Minus 0.693.
And the second one?
693.
Yeah. Okay, so there are the two answers for x then. So because of these two answers, the graph must look a little bit like this then. They meet somewhere here and somewhere here. Symmetrically. Because they only differ by sign. Yeah.
Could I have the time on that?
Yeah, the time for that one,
Same place?
34.
the same thing, positive and negative won't stay with this.
My picture's not so great. So it's minus and plus 6. Actually, do you know what? Do I still have the program open here? We can graph it.
Yes.
Okay, so write this down and then we'll make the graph to see exactly what we have. Are we writing this down? Okay, just make the graph. What was my first one, please? E, was it? 1 plus 2 e power x, like that. And what was my other one?
6 minus 2 by 2
Over,
e power x.
like that. Yeah, so let me graph the first one. There it is. Let me graph the second one. There we go. We zoom out. Oh, they only meet once. So, that means that in my two answers, I should reject one of the answers. Let me go back to the question.
Why is it
I didn't mistype anything. You saw me, did you?
Yeah, but I got 2.
You got I don't think I made any mistakes getting here, did I? Do you know what? We've got a super powerful 1 gig machine here. We can just simply check the answer. First things first, did I type both of them correctly? Yeah?
Maybe you have to put brackets around 2.
No, I think this is okay, isn't it?
Brackets could make a difference.
Solve, expression, solve, whoa.
Wasn't there this website that could do it for you?
Yeah, it's doing the same thing.
Yeah.
No, don't panic, students, don't panic. Solve expression, I only want real ones. Whoa. Okay. Oh, it can't solve it. I'm smarter than the computer. Great. Alright, abort then. Okay. Something's a bit strange with my graph though.
If you use the website, it will show
The graph.
Apple
Yeah.
2 as well.
Does it match my graph?
No, mine is mine.
Oh, so I'm doing something stupid with the graph then. Okay, hang on. Maybe I didn't zoom out enough. I don't know. Graph. That's that one. Okay, graph. Oh, okay, I must have just mistyped something. So there you go. It does have two solutions. And if you look, the first one here is at minus 0.69, and the second one is at plus 0.69.
The x is the same, but the y is different.
Yes.
So how do you find the minus of the y?
Oh,
Plug it in.
just plug it back in. So like,
Oh, yeah.
if I just take those and sub it back into this one, I can get the y. Yeah. Yes. That's what the I have the graph nice here for you if you want to see the graph. So that's why there's two answers here.
Can you
Yeah.
show how they do the graph, like with your
How to get the graph? Yeah. This graph, now just so you know, I didn't ask you for the graph in the question, and they wouldn't ask you for the graph of this one in the exam. But if you were to look at it, this one here, its graph looks like that. But because of the plus 1, it's just raised a little bit. So, it might be like that. And if you were to look at this one here, that looks like this. Which we learned is the graph like that. However, because of the 6, what happens? Is raised up, yeah. So in fact, it gets raised up to this point so that it crosses twice. Now that's a little bit advanced for semester 1 exam. You wouldn't be asked to graph this. In semester 1, they like to keep the graphs to just this. Okay. Right, so you need to write this down, yeah?
Can you try the extension that I asked earlier?
The one you asked? Okay, in 1 second, or we'll do that. Well, unless people already have this. Do you have this written down? Yeah. Right. This question is actually from an exam paper. So, can you read it out?
4 to the power of x
Yeah.
minus 3 to the power of
X plus 2, like this.
2. Yeah. And then
Plus 2, like this.
and this equals 0.
Ah, this one's a little different. Not much, a little different. Okay, so let's have a look at this one. What should I do first?
Make the two.
Yeah, I should change this into 2 squared. And I should change this one into 2x, like that.
Yeah.
Plus 2 equals 0. So this becomes 2x squared minus 4 times 2x plus 2 equals 0. Yeah, 2x as the subject in the quadratic. No roots here. No roots here. No roots, right? Well, what?
Should be one root.
No. You can have. Well, sorry, I don't mean to say no roots. What I mean to say is no factors. No factors.
2 plus x.
Yeah.
It does give you an answer, but it doesn't numerical.
No, I know this. I'm saying, listen, no factors. So we have to use the quadratic formula.
How do you know that?
I cannot think of 2 numbers that multiply to make 2 and add to make 4. Yeah. Well. No, I know. Okay, everybody just stop talking. You're telling me stuff I know. Just be quiet and watch. So what I'm going to do next is use the quadratic formula. So that is minus b plus or minus the square root of b squared, which is 16, minus 4ac. So that's minus 8.
Yeah.
All over 2a. So that's 2.
No.
What's wrong?
It is 1. Because x is supposed to be 2 is x.
This is a 1 here, isn't it? 1 minus 4 and 2. Do I need to use colours? This is like the x squared and this is like the x. And then this guy here, this is a, this is b, and this is c. Is this okay or not? I know you're thinking about lunch now. Just hang on for a few more minutes. So this is 2 power x equals 4 plus or minus root 8 over 2, which is 4, listen, 4 plus or minus 2 root 2 over 2. Yes?
Yeah.
So this is 2x equals 2 plus or minus root 2. Okay? Now, I need to figure out what the x is. So you can say
Log.
x is log base what? 2 plus or minus root 2. Because you're literally asking 2 to what power gives me this number I have here. Now, I think 2 plus root 2 is okay, and 2 minus root 2 is okay, because you can't have logs of negatives. Yeah. So, if we just bash that into the calculator, oh, you have them already, what is it?
Minus 1.4
Yeah?
and 0.513 something.
0.513, okay. Right, now, let me just check this.
That's not true.
Which one? Is this not right?
Yeah.
Okay, well, let me just type it in here. Log base 2, 2 plus square root 2. Oh, okay. 1.77, or My second answer,
Minus 0.77.
minus 0. Okay, it's just the minus 0.77. Now look, these numbers are a bit strange. If this was an exam, you should be thinking, perhaps I made a mistake. So to reassure yourself, we should sub in one of these values back to the original to see if we do indeed get 0. So let's see. I'll sub in this value, okay? So it's 4 power the number I just got, minus 2 power the number I just got, plus 2, plus 2. What should I get here?
0.
Which I do. So it's it's impossible for me to imagine getting this one right and the other one wrong. So I have good reason to believe, and I can check very quickly that my answer is most certainly right. Okay. This is a hard one. It's a hard one for sure. I think this is the hardest one you could get in the exam on this topic.
Couldn't you do alpha replace and check that way on the calculator?
Which one?
This is something,
Alpha beta?
No, the difference of alpha replace to basically write out the equation.
On the calculator?
Yeah.
Yeah, you could.
Give the
Yeah.
value
No, I
of
know
alpha.
this one. You could. Right. Just for a couple of minutes, I just want you to try at least one of these before you go. Listen, the last one in each, okay? So 1Z, 2Z, 3Y, 4C, 5C, and number 6, okay? No, I'm too tired to repeat. Ask someone who was listening, thank you. OMG. Listen. 1Z, 2Y, 3Y, 4C, 5C, and 6. The last one in each.